Unit 19, Day 2, Recursive Geometric Sequences. Alright, so yesterday we dealt with primarily just what's called the explicit form of a geometric sequence. Today what we're dealing with is what's called the recursive form. And basically all the recursive form is, it just uses the previous term to define the next term. Alright, so as an example, okay, it gives us that a sub 1 equals 3 and a sub n equals 4 times a sub n minus 1. Alright, so it says that we use a sub 1 equals 3 in the recursive formula to find the next 4 terms. And all it does is it takes 3, multiplies it by 4 to get 12. 4 times 12 is 48. 4 times 48 is 92. 4 times 92 is 768. And basically you keep on going all the way down until you find as many as it asks you to. Alright? So on these, okay, it's asking us to do the exact same thing, okay? It's asking us to find the first 5 terms. So they go ahead and they give us the first term. So that's going to be negative 4. Alright, the next term is going to be 3 times negative 4, which is going to be negative 12. And then we're going to go 3 times negative 12, which is going to be negative 36. 3 times negative 36 equals negative 108. 3 times negative 108 equals negative 324. Alright, so that's 1, 2, 3, 4, 5 terms. Done. Alright, so the thing is, this recursive formula, all that we're going to do is we're going to take this number right here that's attached to the a sub n minus 1, the negative 3 here, the 1/2 here, and multiply by that to get the next term. Alright, so for number 2, we start off with 5. That's our first term. And we got 2 times 5, which equals 10. 2 times 10 equals 20. 2 times 20 equals 40. 2 times 40 equals 80. And there you have it. Alright, let's see, we got a sub 1 is 6, so we go 6 right there, and we go negative 3 times 6 equals negative 18. Negative 3 times negative 18 equals 54. Negative 3 times 54 equals negative 162. And then negative 3 times negative 162 equals 486. Alright? Alright, next one. We got 400. And we're going to do 1/2 times 400 equals 200. 1/2 times 200 equals 100. 1/2 times 100 equals 50. 1/2 times 50 equals 25. These should be getting really easy for you at this point. Alright, number 5. Okay, we start off with 12. Okay, 2 times 12 equals 24. 2 times 24 equals 48. 2 times 48 equals 96. 2 times 96 equals 192. Let me go back and make that actually look like a 96. There we go. Alright. Last one, okay, on this side. We got -1. And then that's going to be 4 times -1, which is -4. 4 times -4 equals -16. 4 times -16 equals -64. 4 times -64 equals -256. And this side is finished. Alright, side 2. So we're doing the same thing for 7 and 8 that we were doing on the previous page. Alright, all we have to do is start off with 64 on this one. And then we're going to go 0.5 times 64. That's going to be 32. Let's make that look like a 32. Point 0.5 times 32 equals 16. 0.5 times 16 equals 8. 0.5 times 8 equals 4. 1, 2, 3, 4, 5. Okay, got my 5 terms. Alright. Next piece, okay, number 8. Alright. We actually start off with 8 on this one. And it's going to be 1.5 times 8, which equals 12. And then 1.5 times 12 equals 18. 1.5 times 18 is going to equal 27. And then 1.5 times 27 equals 40.5. Alright? Now, next problem. It says to write a recursive formula for each of those sequences. Okay? Well, I don't know if y'all have noticed, but so far all that we've actually needed to find is the common ratio. Okay? And the common ratio is really easy to find. Okay? You take the second number and divide it by the first number. Alright, so R equals 66 over 22, which equals 3. So what we are going to say on this is that A sub 1 equals whatever the first term is, which in this case it's 22. And then A sub n equals 3A sub n minus 1. Alright, don't forget your commas. And also never forget that n has to be greater than or equal to 2. Alright, now we're going to do the exact same thing for number 10. Okay, we're going to calculate our r. That's going to be 16 over negative 8. It's going to be negative 2. So, what we say is we're going to say A sub 1 equals negative 8, and A sub n equals negative 2 on the outside, let's see, with A n minus 1, and we can never forget n greater than or equal to 2. These all have to have that. Alright? Because you can't exactly recursively define the first term. It doesn't really make any sense. So, anyway, number 11. Alright, number 11. We've got A sub 1 equals 5. A sub n equals 15 divided by 5 is 3, so 3. A sub n minus 1. where n is greater than or equal to 2. Boom. Done. Alright? And y'all should be able to start breezing through these about this fast. Alright? Let's see. 243. So a sub 1 equals 243. A sub n equals, let's see, 281 divided by 243. If you put that in your calculator, it's 1/3. A sub n minus 1. N greater than or equal to 2. Alright, there's 3 pieces to each of these ones. And it talks about recursive formula. The a sub 1 part, a sub n, and then you got to define the domain of n. All you got to do is just say that n is greater than or equal to 2. It's really easy. Alright? Now, number 13, okay, a sub 1 equals 1,000. And then a sub n equals 200 divided by 1,000 is 1/5. Alright, and then a sub n minus 1. And then n has to be greater than or equal to 2. Alright, last little problem here, number 14. Alright, so a sub 1 equals 8. And then let's see, negative 20 divided by 8 is going to be negative 5/2. So what we need to do is say that a sub n equals negative 5/2 of a sub n minus 1, where n is greater than or equal to 2. 1, 2, 3 pieces. Done. Alright, now, a piece of paper is folded several times. The number of sections into which the piece of paper is divided after each fold is shown below. It says to find the next 5 terms in the sequence. Alright, so find the next 5 terms in the sequence. So 1, 2, 3, 4, and 5. So the next 5 terms, well, we're doubling, right? So 2 doubled is 4, 4 doubled is 8, 8 doubled is 16, and then 32 doubled is, of course, going to be 64. And then 64 doubled is 128. And those of you that are good at data and all that stuff and computers, you'll recognize that these start being numbers that are bit sizes and stuff like that, and byte sizes. 512 and then 1024. Alright, so that part's taken care of. We got 64, 128, 256, 512, and 1024. Alright, so write a recursive formula for the sequence. Well, this is easy. We say a sub 1 equals 2. And then we go ahead and say a sub n equals 2 on the outside of a sub n minus 1 when n is greater than or equal to 2. 1, 2, 3. Done. That says to write an explicit formula for the sequence. Now, explicit formulas are what we dealt with yesterday. So what we can do is we can say a sub n equals, let's see, what was our initial term? 2. What is our r? Our r is 2 for this, and it's raised to the n minus 1 power. That is our explicit form. Alright? Next problem, and last problem. A recursive formula for the balance of a savings account, a sub n in dollars, at the beginning of year n is a sub 1 equals 500, a sub n equals $1.05 times a sub n minus 1, and n has to be greater than or equal to 2. Write an explicit formula to represent the balance of the savings account a sub n. Alright, so this is easy. Okay, it just says to write an explicit formula. Alright, now if you remember correctly, our explicit formula starts at a sub n. Alright, we have our initial value. And then we have our R, which is going to be 105. And then we just raise it to the n minus 1 power. And that's the end of that problem. And the end of the notes.